Welcome to my channel. In this video, I'm going to show you how to display the view, the surface color in this manner. In your HFSS design, you might be interested in the color distribution, the field distribution, and this is video uh, for you. So the first thing that I need before doing anything, the first thing that I need will be to delete all the already displayed uh, graphic. So I will just go to HFSS and under the HFSS tab, you will end up with a pull-down menu with a number of options, and the item that you need to choose is fields. And from the field options, you can go down and then choose delete plots, and where you can delete all the already plotted graphics. So now I am with a clean plot. And the next thing that I'm going to do is to make sure the simulation is done. And also in the simulation, you also need to make sure you have saved all the field data. The field data here will be used for displaying the far field and also the near field. And what we are going to display is the near field only. I have already done the simulation. I'm not going to redo it again here. So I will just OK this one, and I have already done the simulation, and you can see it. Yeah, I've already done the simulation. Okay, the next thing that you are going to do is to select all the solid objects, and I will just select the substrate and all the metallizations. And you go back to the HFSS tab, and under the HFSS tab, you select fields and then plot fields. And then E stands for electric field. And you are going to display the magnitude of the electric fields only. So I will do that. I will end up with a window where I can choose the frequency of choice. And in this design, I will just choose 13 gigahertz. So anywhere where close is enough. So I don't think you need to change any other options here. And I will just do it. So basically, you are almost done. But the problem is the field is too weak. You can hardly see any visible fields in this design here. The reason is because the default upper limit of the electric field is too high. 48 kilowatts per meter is a strong magnetic electric field, and you need to lower the limit in order for these displays to be clearly visible. So what you need to do is to lower the limit. To do that, you just go back to HFSS, fields, and modify plots attributes. And you just do that, and you end up with a window with a number of tabs here. And the tab that you are going to choose is the second one, scale, where you can change the limits, the minimum limit and the maximum limit. I will just choose this option, and instead of using 48,000 volts per meter as a upper scale, I will just tune it down. So according to here, yeah, I end up with a really light blue clouds around this metal segments here. And if I can display it to you, Yeah, it's like this, right? So this color corresponds to 9,000. So we just lower this value to 9,000. 9,000 walks per minute. Okay, or per meter. Sorry. Okay. So now the electric field become much clearer now. Uh, so I will just so this is the electric field part, and the maximum electric field is not on the tapered region of the antenna. Instead, is around this area. Yeah, around this area. And I can also clearly see that this corner here is where the maximum electric field is. So this is not wanted, and this region can distort the far field pattern. Okay, so the next thing that I'm going to display is the magnetic field. And before doing anything, I need to clear the already displayed graphics. I will do that. Go back to the HFSS tab, Views, and then delete plots. Okay, so I'm going to choose all the objects again. And then HFSS, Views, and then Part, and then H stands for magnetic field. And here you will end up with a window where you can choose the frequency of choice. So I will just choose this one, right? And I will just do it. Yeah, you will end up with a plot, but the plot is not clearly visible enough. And you need to lower the upper limit of the magnetic field. In this case, I would say, yeah, I can see there's some color division here. Yeah, I can zoom in, do it again. Zoom in, yeah, you can see that only this region. So theoretically, I need to change the upper limit to around the value that match to this color. Yeah, and according to the color here, yeah, the this color is equivalent to 100 watt, 100 ampere per meter. So I just need lower the limit. So I do it again. Go back to the HFSS tab, Views, and then uh, modify port attribution, and then scale, and then use upper limit. And instead of using this file, and you just choose to 100. Okay, so it's now visible now, and you can see it. Yeah, and it's still not really visible, right? Because other area is not clear. So you can further lower the upper limit of the magnetic field. So I will do that. So now is much clearer now. Yeah, much clearer now. Yeah, you can see it here. Sorry. Yeah, it's more visible now. Yeah. So the maximum magnetic field is around this region. This is where uh, the end-fire radiation is created. Okay, so I'm going to delete this spot and begin displaying the surface column. The surface column. So again, before doing anything, you need to choose all the objects and then delete, and then go back to the HFSS tab, fields, and then choose the J stand for surface column density, and then I will just plot the magnitude of the surface column density. And again, you can choose the frequency, and we choose this one, yeah. And before going on, before moving to the next step, I would like to highlight that you have some more options to choose here. When you display the color, first, right, there shouldn't be any color in the three-dimensional space. So the color should be on the surface of metal or whatever. So I will just plot on the surface only. Okay, so I will just do it again, right? You can clearly see the maximum surface current density is here, and corresponding to the color of this region, the current density is around 50. Yeah. So if I were you, I would just lower the maximum surface current density to 50 ampere per meter. So I will just do that. Fill surface HFSS tab, and then fields, and then modify plot attributes. And then in the window, you choose scale, and then limits, and then 50. So you can clearly see how the surface current densities appears in the final design. And surprisingly, the surface current density at this region is comparable to the surface current density at the input port. Perhaps this is the main reason how you end up with the maximum magnetic field there, and how you end up with end-fire radiation from this antenna. Okay, if you have any further question regarding this video, please leave your question to the comment section. For now, that's all. Thank you.